Okay, let's start something. I'll open up Chrome. I'll type in a question: is the moon coming closer to Earth? Yeah, is the moon coming closer to Earth? Let's see. Nah. Why does it say? What does it say here? This article says like why the moon is getting further away, so it's going away from us. But the next article says like the moon is coming down to the Earth, so it's getting closer to us. So you can see like how reliable Google really is. You get like the two opposites here. One says the moon is going away from the Earth, and the other one says the moon is more or less like crashing into the Earth. So which one is actually true? Let's calculate this stuff. Now I think you need two type of like we'll do a couple of calculations. First of all, like what type of force does the Earth have on the moon? Okay, so we need to get a couple of like constants in place. So we have this thing called a gravitational constant, which is here. We've got a number, big number. Let's copy it. Right click, copy. I go into Excel, zoom in a little bit with Control and rolling my mouse wheel. I'll do a paste special of some text, so you get that number in there, okay? So actually I don't want that number in here. I'll just click and drag it to somewhere there. So we have like G, the gravitational constant. So gravitational constant. Yeah, double click there so you can see the whole text. Now this is a number, of course. We want that number. And this is 10 to the power of minus 11. In Excel notation, it's like E minus 11. And all that other stuff there, I'll just do a Control X, cut it, and hit Enter. So we now have a number there. And that other stuff I'll paste in here with Control V. So what we want to keep there is just those units. Yeah? Is that okay? Yeah, it's a number there. Okay. Then we have the mass of the Earth, I guess. The mass of the Earth. And I'll get that from NASA somewhere. So mass, Earth, NASA. There you go, there's a number. Ah, let's just copy the number, there you go. Copy, back into Excel. Oh, Control V, paste it there. Oh, Control Z, I want to paste it as text. Paste special as text. Okay. Yeah, and I was in kilograms. I double click here between C and D so you can see the whole number. Actually, I don't want to see this as a number. I want to get it in scientific notation. So I'll change it from number here to, where is it? Scientific. There you go. Looks a little bit better, so I can double click again. Takes less space. Then I have the mass of the moon. Mass of the moon. Let's look it up again. Google. Mass of the moon. There you go. According to NASA, of course. Let's stick to NASA. Here you go. 10 to the power of 24 kilograms with this number in front of it. So I'll do a copy. I'll do a paste special of text. Okay. I'll add there e to the power of 24, which is kilograms. Oh, I said kilograms. And then I need a formula, of course, like how do we calculate the force? So gravitational force calculation. There you go. Formula maybe, not calculation. Let's go. Formula. There you go. This one. So what I'll do, I'll add I'll use my snipping tool. I say new. Just let's grab a copy there, so I can actually see it. Oh, bang. So edit and copy. And you can actually see all the descriptions. F is the force, G is the gravitational constant. Then we've got the two masses of the objects, and R is the distance between the centers of the masses. Okay, cool. So did I do a copy here? Edit, copy. Back into Excel. I'll chuck it here, so Control V, so we have it there. Okay, it's just a picture. So, okay. So F the force, Earth, Moon. Okay. equals what? Equals opening bracket. So that is like G, this number, times this number. I just click in there. Times that number. Divided by, well, for now 1, because of course I didn't put the distance in there. So what I'll do, I'll just delete it again. I'll move this one down. One cell, click drag. So distance, Earth, and I can't type. Distance, Earth and Moon. Let's get that from NASA again. So distance, Earth, Moon, NASA. There you go. About 240,000 miles. In kilometers, it says here 385,000 kilometers. Okay, 385,000 kilometers. So 385, 123,000, 123 meters. There you go, from kilometers to meters. So now we can actually calculate that force, I hope. So equals, opening bracket. That's G times mass 1 times mass 2, closure bracket, divided by this thing to the power of 2. There you go. 1.97 e to the power of 20 newtons. So that's the force, okay? Going from Earth. Actually, the force that Earth has on the Moon. Of course, the force is pointing towards Earth, not away. So let's make that a minus. Does it make sense? So if it's going away, the force, then it's plus. If it's going towards us, it becomes minus, I think. So, okay. Then we have something else. That's the force. And of course, if that force would just be in place, then the Moon would just like go away. Actually, no. If that force would just be in place, then the Moon would actually fall onto the Earth. So there must be another force that actually like pushes the Moon away, and that's a centrifugal force, the centrifugal force. Because if you like swing a bucket around with water on a rope, then of course like that bucket wants to fly away. You know the feeling that like there's actually a tension on that like rope you're holding in your hand. So that comes from the centrifugal force. So let's do another. Let's find up another formula. Let's find another formula then. How do we calculate that thing? So formula centrifugal force. There you go. F equals m angular velocity squared r. Okay. Okay. Angular velocity. Okay. Let's copy that again. New. I'm just going to go click and drag. And we'll go edit, there we go, copy, back into Excel, let's do a Control V here somewhere, paste it. Okay, so, do we have other formula centrifugal force? Another one here, look at this one, F equals mv squared divided by r, another one here. mv squared, I'm just going to copy it, edit, copy. That's this little thing here. I knew this one. Yay. Looks a little bit easier. Edit, copy, Excel. Doesn't really matter which one you use, okay? There you go. V squared. So what do we need? We need like the m of the Moon we already have. The r we already have. That's the distance between the Earth and the Moon. So we need like this v squared thing. This v squared thing. So how quickly does the Moon actually circle around the Earth? Now the first thing we need is like, so what's the period then? So how long does it take for the Moon to make one cycle around the Earth? I don't know. Let's ask NASA again. So period Moon cycle. There you go. Period Moon cycle. It says here, how long? No, I don't want that one. NASA. I'll just add NASA there. The cycle repeats once a month every 29.5 days. Daisy. long? I know it's a. How long does it take? How long does it take for the moon to complete one revolution around the Earth? Ah, there you go. that's better. 27 days, 7 hours, and 43 minutes. So what I'm going to do, I'm just going to copy that. Edit copy. We're getting there. Back into Excel. Let's paste it again. Control V. Let's check it out. Make it a little bit smaller. It's a bit big. So 27 days. How many seconds is that? 27 days. Let's check it over here. So P moon, period of the moon, equals what? Equals 27 times 24 hours. Every hour has 60 minutes, and every minute has 60 seconds, plus, opening bracket, 7 hours. Every hour has 60 minutes, and every minute has 60 seconds, plus 43 minutes. That we just need to multiply by seconds. That's the number of seconds, isn't it? For the moon to make one revolution around the Earth. So I'll just chuck this one there. Yeah, that makes sense. How long is that orbit? How long is that orbit? Well, the size of an orbit is like 2 times pi times r, if I'm not mistaken. Is that correct? Let's check it again. Size of a circumference of a circle. Yeah, 2pr. So again, I'll copy it. Edit. Okay, no. File new. I'll just copy it. Whee! Edit. Copy. In Excel. Let's chuck it there somewhere. Control V. So that's like the circumference equals 2 times pi, let's type in pi with brackets, that's the constant pi, times r, and r, we already have that somewhere. R is the distance between the Earth and the Moon, and that's that one. So that's in meters, isn't it? That's in meters. So then the speed, I'll just call it v underscore moon, v velocity of the moon, is, well, meters, how many meters per second? So that's that, meters, divided by the number of seconds, isn't it? That's the speed in meters per second, so meters per second. There you go. And finally, we can start to calculate the v underscore centrifugal force. That equals m of the moon, which is that one, times, what was it again? V, wasn't it? V squared. So v moon, that's that one to the power of 2, divided by r. What's r? R is the distance, wasn't it? Distance r moon. Here you go. D, C4. Enter. Oh, look at that. Look at that. They're almost the same. So this is like the force that the Earth has on the moon. So this force causes like the moon to move towards the Earth. This force actually pushes the moon away from the Earth. And guess what? You see, they're almost the same. And that's why the moon kind of like stays in orbit, because they're almost the same. If they will be exactly the same, then the moon will always be fixed in exactly the same position. But right now there's a small difference between those two, a very small difference. So there's one more law, that's, I think, Newton's first law, if I'm not mistaken. I may be wrong, okay, I'll just type in Newton's first law. What is Newton's first and second law? Here you go. F net equals m times a. So the force equals the mass times the acceleration. Okay, let's copy that again. New. I'm just going to copy it from here. Whee! So, edit. Copy. Back in Excel. Control V. Make it a bit smaller. So, what am I looking for? I'm looking for the acceleration. So the acceleration equals, if A equals m times A, then A equals F over m. So what is F? Well, F is the net force, of course. So the net force is that, agree, plus that's remaining force. And we want to do what with that remaining force? That's the net F. We would just want to divide it by, m. M of the moon. That's this one. Close your bracket. Oh look, that's really, really, really small. F is m over A. Is that correct, by the way? Is that correct? I just want to make sure that I'm doing the right thing. So the force equals this plus this. Yeah, that's okay, I think. So equals, let's do it once more. A is F over m. So F is that plus that divided by m of the moon. M of the moon, that's that one. Yeah, okay. So that's meter per over squared seconds. So that's really, really, really small. If I make that a number, you can see you can't even see it. It's so small. So in other words, like, I mean, this is just showing that the moon is moving away from the Earth, but very, 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 very slowly. This is just physics in a nutshell. I mean, I hope this is kind of correct. If anyone has any remarks to make, feel free. But yeah, I mean, if you don't trust Google, you can always trust Excel and use Excel as a small calculator. Grab the various formulas from the same internet, which isn't always reliable, and also hoping, of course, that all these constants here, all these values are actually correct. Now, of course, like the orbit isn't completely circular and all that stuff, but I mean, it's a start, isn't it? I mean, it's fun to do these calculations yourself, and you can actually see that like these two forces, at least, I mean, this one and this one, they're almost the same, which makes you believe that, like, yeah, the moon is kind of like in a stable orbit around planet Earth, which is probably a good thing. But again, looking at this little value here, it's pushed away very, 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 very slowly by the centrifugal force. Anyway, it was just a bit of fun, okay, because I came across that like thing on Google where it had like two of those two opposite like outcomes. One saying like the moon is coming towards the Earth, and the other one is saying like the moon is drifting away from the Earth. So I went like, which one is actually true? And I mean, according to these little calculations, of course, like based on Newtonian like physics, I mean, it actually gives you a kind of an answer. So have fun with it. Bye bye.